Um, Welcome back. This video is for college algebra. I'm still on section. I'm actually back on section 7-1 here. Had a request for maybe explanation on some of the word, how to approach some of the word problems. So I may or may not work out an entire problem here, but maybe we can at least get started. The first problem I'm going to look at is problem number 12. Okay, so if you're following along at home and you want to pause the video and go to problem 12 for a second, you're certainly welcome to. I'll read it though. It says a coin bank, okay, like a piggy bank, right, contains only dimes and quarters, and it has 13 more dimes than quarters. Okay, so it's got dimes and quarters in it, and there's 13 more dimes than there are quarters. Okay, now I don't know how many quarters are in this bank. I don't know how many dimes are in this bank, but I do know that there are 13 more dimes than there are quarters. All right. Well, let's start with this. Let's consider the fact that, something I said, I don't know how many quarters are in this bank. I'm gonna look, if I don't know something and I want to know it, okay, like I want to know how many quarters are in this bank, I'm going to use a variable to represent that. So I'm going to let Q be the number of quarters in the bank. Okay. Now, so if somebody asks you, hey, how many quarters are in that bank? You could tell them there are Q quarters in that bank. That's how many quarters are in that bank until we know more about it. Okay. Can you see this okay, Eliza? The writing? Yeah. Okay. Now, another thing that I don't know and I want to know is how many dimes are in this bank. Well, anything that I don't know but I want to know the value of, I'm going to use a variable to represent it. So I'm going to use a D for the number of dimes. Okay. Now, at the end, if you look at the two boxes there, you're expected to find, how many quarters are in the bank and how many dimes. And you can't just type in Q and D. Okay, but for now, that's all we know. Now, I mentioned earlier, it says in the problem, and your numbers may differ from mine, there are 13 more dimes than quarters. So listen, if I have two unknowns, I have got to find two relationships between those two unknowns. Okay. Well, one thing I know is that there are 13 more of these than there are of these. So let's think. If I wrote Q equals D. Eliza, is that true? No. Because there's not the same number of quarters as there are dimes. Okay? So I've got to think, well, how can I make this equation true? Well, I know there's 13 more of these than there are of those. So if I want to balance this equation, what do I need to do?
Q plus 13 equals D.
Since right now this is 13, this number is 13 bigger than this number. If I add 13 here, now I have a relationship that is correct. Okay? The number of dimes is equal to the number of quarters plus 13, because there have to be 13 more dimes than there are quarters. Okay. Well, I said we need two relationships. Okay, and there's something that I haven't told you yet, but if you are reading the problem at home, you already know this. I need to form another relationship. There's two unknowns in this equation. I can't really figure out either one of the values just yet. So I'm reading in here. It says the total value of the coins is $4. And the total value of the coins is $4. So if I take all my quarters, add all my dimes, okay, I'll have a total amount of money of $4. Well, Eliza, how much is a quarter worth?
25 cents.
Very good. Yeah, 25 cents. And of course, a dime, this is a little tougher.
I don't know.
Okay, so a dime is worth 10 cents.
Oh,
10
man.
cents.
I was going to guess 5.
Yeah, well, welcome to America. So yeah, each quarter is worth 25 cents. Each dime is worth 10 cents. And I know that. Okay, now let's see. How many quarters do I have, Eliza?
Q.
Q. Good. Yeah. So if I had 4 quarters, I think everybody'd be able to figure out how much money I have in quarters.
$1.
$1, because 4 times 25 cents makes $1. Okay. 5 times 25 cents would make
125.
125. Yeah, but I don't know how many quarters I have. I just know that it's Q. So the total amount of money that I have in just quarters is just, I'm going to take my number of quarters and take it times 25 cents. Okay? So this is the total amount of money that I have just in quarters. If I added up all my quarters, I'd have this much money. But I've also got some dimes. And remember, Eliza, they're worth 10 cents each, right? So I'm going to add to my money that I have that is tied up in quarters, I'm going to add the amount of money that I have in dimes. Well, that's going to be 10 cents times the number of dimes, right? I take 10 cents times, say 9 dimes would be 90 cents. That gives me my total amount of money in dimes. And I know that if I add up the total amount of money I have in quarters plus the total amount of money I have in dimes, it says that I get a total value of $4. Okay. Now, if you look at that, now I have a relationship here between Q and D. I have a relationship here between Q and D. Now that I mean, you've got 2 relationships now, right? So now you can use. You remember that this whole section was about how to solve a system of 2 equations and 2 unknowns. So feel free to try elimination, substitution, whatever the case may be. Okay. Now, to be honest, I pretty much did that problem for you. Eliza helped a bit. The next problem, 13, I'm going to try to do a little less. This is the one about a woman paddling a canoe, okay, downstream. And it says she travels 20 miles in 2 hours. And then she paddles back upstream against the current. And it takes her 5 hours. And it asks you to find the rate of the boat in calm water and the rate of the current. Okay. Well, I'm going to write a few facts up here, but like I said, I'm probably not going to do this whole problem. I know, for one thing, Eliza, do you know a relationship between like the distance that you travel and how fast you travel and how long it takes?
What?
Do you know a relationship between those 3 quantities? Distance and your rate and your
Oh yeah, distance divided by time
equals
rate.
Okay, that is one way to remember it. I usually remember it as distance equals rate times time. Okay. Now, the distance, they're going to give you a couple of distances there. If she travels 20 miles downstream, she's going to travel 20 miles upstream as well. Her rate's going to be different, and that's something you're going to have to solve for, I suppose. And then it gives you a couple of times. So I'm going to kind of leave it up to you on this one. If you want to take a picture of your work and send it to me, if you're having trouble getting the right answers here, you're welcome to. But just define your variables. Okay. You'll need 2 relationships. I promise you, this will be a 2x2 system that you'll be able to solve. Eliza, how are we doing time-wise?
8:59.
Okay, I tell you what. Let's I feel like I am going to have to give some direct instruction on number 14, which is a mixture problem. Okay, mixture problems used to be a mainstay of Algebra 1. They're no longer really in the curriculum for Algebra 1, but that doesn't mean they're not important. So if you read number 14, on 14 here, it says an experiment calls for a 5% salt solution. Okay, this experimenter wants to have a solution that is 5% salt. But it says only a 3% salt solution and an 8% salt solution are available. How many gallons of each must be mixed to obtain 30 gallons of a 5% salt solution? Okay, so you've got a solution, you've got a cup of, or I guess a big barrel of solution that's 3% salt. The rest of it's water, in case you don't know what a salt solution is, I'm mainly explaining this to Eliza.
I knew that.
You stir some salt and some water, it dissolves, and you get a solution. And this solution is 3% salt. Then you've got another barrel full of a solution that's 5% salt. Okay. But you don't want well, I said that wrong.
8%
8% salt. Thank you. You have a barrel of 3% salt solution. You have a barrel of 8% salt solution, but you want 30 gallons of 5% salt solution. And how much do you mix in of each? The 3% and the 8% to get a 5%. Well, I'm not going to do the whole problem, but what I will do is I want to show you a procedure that works for mixture problems. Okay. I don't know where I'd be without this procedure. Okay. I certainly wouldn't be creating 5% salt solutions. Okay, here's what you do. Draw a rectangle, right? Now, here's what you do. I'm always going to make 3 rows. 1 row each for the 2 solutions that I'm mixing together, and then 1 row for the mixture. So this is going to be the 3% solution. This row is going to be for the 8% solution. And then this last row is going to be for the mixture, which is a 5% solution. Okay? Now, I'm also going to divide this into 3 columns. Okay? So what I'm going to do is I'm going to do the first, I'll just make the percent of, in this case, salt. And I'm going to write it as a decimal. Okay, so like for instance, this 3% solution, I'm going to say that the proportion would actually be a better title for this column, is 0.03. That's what proportion of this solution is salt. This would be, of course, 0.08, and our mixture we want to have a salt proportion of 0.05. Okay. Next, we're going to make a column for the amount of solution. Not the percent of the solution, but the amount of solution. Eliza, can you read this?
Yes.
All right, that says the amount of the solution. Now, I don't know how much of the 3% solution I'm going to pour in. I don't really know how much of the 8% solution I'm going to pour in, right? Okay, but I do know how much of the 5% solution I want. How much do I want, Eliza? Do you remember?
30 gallons.
30 gallons. So I know I can put a 30 here because that's the amount. 30 gallons is the amount of solution that I have here. Well, okay, now here is the not tricky part. We'll see how Eliza does. Eliza, if I don't know how much of this solution I am going to put in, what should I put right there?
A variable.
A variable. What's your favorite variable?
X.
Okay. She's very traditional, right? Okay. Now, what about right here?
Y.
Well, I could. Okay, I could. But Eliza, let me ask you a question. If I had 15 gallons here, how much would have to be here?
15.
How'd you get that?
30 minus X.
Ah, yeah. So if there were 10 gallons here, there'd be
20.
Because 30 minus that
X.
is, yeah. So I know that this plus this has to equal 30. So what I can do here is just write 30 minus X, okay? X plus 30 minus X will give you back 30. And then the final column is the amount of, in this case, salt. Okay, not the amount of solution, but the amount of salt, okay? Well, to get the amount of salt, if I have, for example, let's just do the easy one. If I have 30 gallons of a solution and 5% of it's salt, how do I figure out how much salt is in it?
Oh, that's this answer?
Yeah, go ahead.
Multiply.
Yeah, you multiply it, right? Yeah, 0.05 times 30. You get that answer, okay? That times that should give you this. That times that should give you that. And then it's this final column that I think is easiest to use to form an equation, okay? Because if I take the amount of salt here and the amount of salt here, how is that related to the amount of salt here?
It is. I don't know what you mean.
Well, you remember you're taking this solution,
Yeah.
dumping it together with this solution to get this solution.
Yeah.
So essentially, the amount of salt in this solution plus the amount of salt in this solution should give you the amount of salt that's in your mixture. Okay. I'm going to leave it there. Listen, again, feel free to email me a picture of your work if you want me to look at it, if you can't seem to get the right answer. Thanks, that's it. Maybe we'll come back another day. Bye.